All right, so here goes. Unit 3, review bell work. Number 1 and 2 has to do with the inverse function. So there are two ways to represent the inverse, right? One way is put that -1 as an exponent, or another way to say it is like an arc in the front. Eventually, the inverse, both are the same. So, for example, this one, you can say the tangent inverse of a tangent, or you can also say arc tangent, and still it means the same. For the you also have to remember the domain restriction for that. So for the inverse sine function, your answer can only come from the first and the fourth quadrant, and it has to be greater than -half the pi, less than half the pi, greater or equal to. If it's the inverse cosine function, your answer can come from 0 to pi. If it is inverse tangent, same thing as a sine, -half the pi to half the pi, except you can't have those two values. Okay, all right, so let's go to letter A, inverse of tangent -1, set that equal to theta, because that's what we're trying to find. That's the ratio it's given, what's the angle. Now you go put it back to the original. So this means tangent of theta is equal to -1. Now you're going to find the angle given the ratio. Okay. You kind of have to remember the little cheat sheet of the tangent one, right? You don't have to memorize it, this one, because I think you can quickly generate this on your test. So we got pi over 6, pi over 4, pi over 3. So what's the tangent of pi over 6? Radical 3 over 3. Tangent of pi over 4, same number, so y over x is 1. Tangent of pi over 3 is radical 3. So the fact that y over x gave you -1, I know that it has to come from the fourth quadrant, not the first. Since it's a negative, it has to be the fourth quadrant. Particularly, that means y and x are the same value except they are the opposite. So I know on my unit circle in the fourth quadrant, that's going to be 7/4 the pi. However, remember for inverse sine function, it has to be negative angle, right? -half the pi to half the pi. So I'm going to find the coterminal angle of this by subtracting 2 pi. Which is -1/4 the pi. So your answer, if you put 7/4 the pi, that is wrong. You gotta put -1/4 the pi. Okay? Alright, let's keep going. Set that equal to theta. Secant of theta is equal to -2. Well, I don't know a secant, so I'm gonna put it something that I already know. What's a reciprocal of the secant? That is cosine of theta. What's a reciprocal of -2? -1/2. Right? Because I can't find -2 on the unit circle, but I certainly can find -1/2 on the unit circle. Alright, so inverse cosine has to be from 0 to pi. Which value is going to give me the x value of -1/2? Let's see, x value of -1/2, you're going to put your index finger, because x value has to be the half. Right? So index finger is the denominator of 3. So denominator of a 3, numerator is 2 pi. So answer 2/3 of a pi. Let's keep going. Sine of theta is equal to -radical 2 over 2. Inverse sine function comes from here. Y value is that. I believe that's 7/4 of pi. Right? Which, once again, just like a tangent one, I can't have 7/4 of pi. That's too big. That's greater than half the pi. So I'm going to subtract 2 pi. I got -1/4 of pi as a final answer. Alright, for this type of problem, I gotta draw a triangle. I'm gonna set inside of a theta, parenthesis equal to theta. That means tangent of theta is equal to 3x. 3x is 3x over 1, by the way. So I'm gonna draw my right triangle. Tangent is OA, opposite over adjacent side. So opposite side is 3x. Adjacent side is 1. Find the hypotenuse side by using Pythagorean theorem. 3x squared. Make sure you square the whole thing. 9x squared plus 1 is x squared. X is, I should probably use different variable. A is radical 9x squared plus 1. So that's the length of the hypotenuse side. 9x squared plus 1. Now what are we finding? Secant. So secant of the theta. Secant of the theta, let's see. Secant is a reciprocal of cosine. So instead of adjacent over hypotenuse, I'm looking at hypotenuse over adjacent side, which is radical 9x squared plus 1 over 1, which is radical 9x squared plus 1 is our final answer. Okay? Okay, so equal to theta. Cosecant of theta is 5, 4. Draw my triangle. Cosecant is a reciprocal of sine, so it'll be hypotenuse over opposite side. Hypotenuse is 5, opposite side is 4. Ooh, 3, 4, 5, our favorite. What is the cotangent of theta then? Cotangent is a reciprocal of tangent, so instead of opposite over adjacent, it'll be adjacent over opposite. 3/4 is the final answer. Okay? We gotta memorize this. Like, there's no, what's the word I'm looking for? Negotiation. You just gotta memorize it, okay? Tangent is y over x, so it's gonna be sine theta over cosine. You just have to rewrite the top part, how to rewrite in terms of sine and cosine. So cotangent is cosine over sine theta. Secant is reciprocal of the cosine, 1 over cosine. Cosecant is a reciprocal of sine, 1 over sine theta. Some of you are still confused with the secant and cosecant. That's not good. All right, what about here? Cosine squared plus sine squared theta, that is the first Pythagorean identity. That equal to what? Sorry, it keeps blaring. I don't know why. 1. 1 plus tangent square is secant squared theta. Don't forget, things are being squared here. Okay? Alright, the bottom two are the sine sum difference identity and cosine sum difference identity. In a class, we wrote this over on a whiteboard to memorize it, right? So let's go. Sum sine identity goes sine of A, cosine of B, right? And you add it. So it alternate, and then it goes cosine of A times sine of B. So it goes cosine sine, excuse me, sine cosine AB, cosine sine AB. Although, like opposite mates. Like, that's easy way of understanding it. What about the difference identity? The parts are all the same. So cosine A, cosine B, cosine A, sine B, except if it's a difference minus, it's going to be minus over here. So they kind of match for the sine identity. What about the cosine? And somehow it's easy to memorize the cosine because it goes cosine A, cosine B, sine A, sine B. But the signs are the opposite. So for the sum identity, it'll be minus. Difference identity, it'll be plus. Okay? You gotta memorize it. Yeah. Alright, number 5. Simplify, rewrite in terms of sine and cosine, and then, oops, sorry. Use identity if you have to. Let's see. Maybe. It's not focusing. There you go. Alright, so first, sine cosine. Let's go. Secant is 1 over cosine. X over sine is sine over x. Minus. Sorry, I was making a video and I realized I made a mistake. Alright, minus secant of x is 1 over cosine over 1 over, cosecant is 1 over sine. And now, instead of dividing by fraction, I'm just going to write it multiply by the reciprocal. So, sine of x becomes 1 over sine of x, right? Multiply by 1 over sine of x becomes sine of x over 1. So that big fraction is right here. That big fraction is right here. Do you all see what I just did? Okay, now I should cross that out. So it'll be 1 over cosine x sine of x minus sine of x over cosine of x. I need a common denominator, so I'm going to multiply sine of x top and the bottom of the first fraction. Now that I have a common denominator of cosine of x, sine of x, what is my numerator? 1 minus sine times sine is sine square of x. Alright, this is where I feel like I don't have anything I can do with. I can't simplify this sign. What am I going to do? Maybe, is there any identity I can use? Yes, I can. 1 minus sine square x is same as cosine square x. That's the first Pythagorean identity. Like over here. That one, like if I were to subtract sine square theta from both sides, I get the cosine square theta, right? That's where I got that from, right here. 1 minus sine square x is cosine x squared. Over cosine x, sine of x. Then I can cancel cosine x out. I'm left with cosine x over sine of x. What is cosine over sine? Cotangent of x. Okay? Alright, what about letter B? Let's keep going the same thing. 1 over sine of x, 1 over cosine of x, minus cosine of x over 1. You can do it two ways. You can just clean this up and then multiply by sine of x later, or you can just distribute it. I'm going to clean up inside of the parentheses first, okay? I need a common denominator, so cosine of x, cosine of x. Then I got cosine of x, 1 minus cosine square of x. Do we know anything about 1 minus cosine square of x? Yes. What is that? That's the sine square of x, using the first Pythagorean identity again. I got sine of x, sine of x. I can simplify that. What is sine of x over cosine of x? Tangent of x. So both of these two, I'm using the first Pythagorean identity to keep simplifying. So you must remember that. Okay?